Reimagining the paradigm for a 21st century grid that supports significantly more distributed energy sounds like a very lofty goal. Making this high-minded directive even more challenging is the notion that accomplishing it will require cooperation, coordination, and collaboration between industry, academia, and government. The good news is, it's already happening and working remarkably well. Hello, I'm Cassie Haley, and I'm excited to tell you about the GEARED initiative and why its success has such broad and sweeping importance. GEARED, which stands for Grid Engineering for Accelerated Renewable Energy Deployment, is a federally funded initiative through the U.S. Department of Energy. Through the GEARED initiative, educators are working with industry to establish new and updated curriculum, assuring that current and next-generation power systems workers are fluent in distributed generation and smart grid technologies. As we shine a light on this innovative program, we'll be hearing from administrators, professionals working in the field, educators, and students, all working to make the initiative a continued success. One of the issues being addressed within the GEARED program is the notion that those currently maintaining the grid are finding it increasingly difficult to integrate clean energy technologies while maintaining grid stability.
In the workforce training aspect of our mission, we are looking at very critical needs of power systems engineering that have lagged in the United States for quite a while now. Integrating much larger levels of renewables onto the grid is going to require very specific skills.
One of the many important aspects of the program's directive is to address and update the training of current and future power systems engineers.
We need new engineers and new technologists for the new systems we have. We need to have universities offer more courses in subjects that are useful to us and more seats in those courses. There need to be more professors, more support staff, whatever is needed to do. And we have to make the case that there's a business case there for them. They have to make that investment. There's no doubt about that. And one of the themes is to have some ready-made courses ready to go. And I think that's one of the great things about the Grid Ed project, that we are having utilities get together and develop some of this material in conjunction with a few well-known universities so that people can see it works, it's useful, and hopefully it'll be contagious, they'll adopt it.
The group that I'm in has a lot of seasoned employees, which is excellent as far as day-to-day work, but it also means we're going to be facing a lot of employee attrition. And it's classes like this that really help even people that have been in the industry a long time to just formulate ideas better and understand concepts a little bit better.
I know quite a bit about the modern distribution systems, but there are a lot of issues, a lot of things that were brought up in the course that we don't always talk about to our students. We generally teach our students the fundamentals of power transmission systems, the fundamentals of distribution systems in different courses. And we tell them or teach them power systems analysis, different ways of looking at conventional equipment and how they operate with loads and so on. But what is going on now, as you know, with the grid modernization efforts that are being funded by some by the government and some by companies themselves, utility companies, we're seeing a lot of distributed generation on systems which are not designed to handle those. We're going to have to design certain problems that that our students will be able to handle. And although Tom Short's textbook on distribution system is very extensive and very well written, we might have to take his examples and create some problems for our students to do, which is what our students are supposed to do, solving real-world problems and then learn from those.
These days, we hear a lot about the shortage of power systems engineers, and as you've just heard mentioned, the fact that many within that career field are nearing retirement. The GEARED program addresses those issues with a focus on student training programs and direct collaboration with the power industry.
We found that we were developing the technologies, but what we really needed to do was connect students and professionals to the technology and the skills that they needed to start to innovate and incorporate all of that technology into the grid.
In the past 2 years, GEARD has trained 3,500 students through about 120 classes that were offered through the 3 consortia that we fund. In addition, nearly 1,000 grid operators got their skills improved through the GEARD program.
As a result of newly formed collaborations between academia and the power industry, undergraduate and postgraduate students engaging in study and research are learning to identify and plan for anticipated future technical needs, as well as those of a new, highly skilled power systems workforce.
In 5 years, I can see myself finishing my master's degree in power systems engineering and working with the research and design of new technologies that will contribute to make more efficient the process of generating, transmitting, and distributing the energy that the world needs.
Ultimately, current and future workers must be equipped and ready to step into new specialty jobs armed with the skill set required by a new, smarter grid.
The nation's grid is changing. We have smart grid, we have two-way power flows, and we have distributed generation. This means that we need to operate the grid in a new way.
Along the way, GEARD is working to keep all stakeholders focused on a modernized grid that supports significantly more distributed energy generation.
A GEARD-trained engineer assumes that the grid of the future accepts two-way power flow, and that the grid of the future will be able to incorporate as much distributed solar and other renewables as necessary.
I see myself having a great opportunity working with power system engineering in an industry that works to integrate the renewable energy into the grid in order to keep the world environmentally friendly, cleaner, and safer for everyone to live in.
On the ground, the work of GEARD is visible through academic and industry collaborations under 3 consortia and the Interstate Renewable Energy Council, known as IREC, a not-for-profit organization that serves as GEARD's national network administrator. The 3 consortia are FEDER, led by the University of Central Florida.
The industry is giving us the real-world perspective of what the students are going to be doing when they graduate from our institution. So we try here at UCF, and I'm sure in other institutions as well, to connect the students with industry while they are pursuing their degree in college, with the intent of giving them a very good idea of what they are going to be doing when they graduate, and also with the intent of helping them find the good jobs when they graduate. So that's a very important relationship. We create an environment here in the College of Engineering and Computer Science that partnerships with other institutions as well as partnerships with industry is something that is very important for our successes. And that's what we have advocated with our chairs, with our faculty, and that's how the FEDER has become into fruition, which is a collaboration, as you know, of institutions around the nation, as well as a collaboration with utility companies, as well as collaboration with industry. The second one is that we have created an environment here at UCF where we encourage a culture of creativity and innovation for our students, and a lot of things are happening here at UCF, one of the biggest institutions in the nation, from our students organically.
In addition to FEDER, the GEARD Consortium includes Marmet, led by the University of Missouri Science and Technology, and GridEd by the Electric Power Research Institute, or EPRI.
Our efforts with GridEd will continue as we look at what are the key educational areas, both for professionals in the industry as well as new people entering the workforce.
Each consortium includes partnerships between universities, utilities, and other industry partners, and all consider the work they are doing of critical importance to our nation's energy future.
One of the reasons why the GEARD program is particularly important is because it really focuses on people. Here at the Department of Energy, there's a lot of technology development that's done, but the reality is that you need people to implement those technologies and to do the innovation. And so this is one way that we invest in people.
Important work is clearly being done in pursuit of generating a robust, sustainable, modernized grid, as well as the skilled workforce needed to maintain it. We hope you've enjoyed this look at the GEARD program. We'd also like to acknowledge the Siemens Corporation for their support and willingness to foster collaborative opportunities within academia and industry. I'm Cassie Haley. Thanks for watching.